Okay, today I'm going to talk to you about the Seminar 3, Problem Solving Part 1, with the theory class that goes along with the Numbers and Operations math class with Kendall Jacobs. I was given this problem, Challenge 1. You have 16 gold ingots in a simple balance. 15 of the ingots are pure gold, but one has a small amount of copper in it, hence it is lighter. Explain how you could identify the lighter ingot after 3 weighings in the balance. Can you find the lighter ingot with 3 weighings if there are 24 ingots? Now, look back. Make generalizations. Is it possible to figure out how many weighings are needed for 100 ingots or even 1,000 ingots? I talked at great length with a couple of friends who enjoy math and have helped me a great deal in trying to understand this and problem solve. And so what I'm going to do is attempt to show you what we came up with. So our first grouping we have is the 16. And what I would do is I would divide the 16 into a group of 5, and then a group of 6. So if I put both of these groupings, the 2 5s, on that scale, and they weigh the same, then I know I need to move to the 6, which I'll talk to you about in just a minute. But if these happen to be different, say this one right here is the heaviest, then I know that this one contains the copper. I just don't know which ingot yet has the copper in it. So what I'm going to do then next is I would divide that grouping into 2, 2, and 1. And again, I'll weigh my 2's first. And if they weigh the same, then I know that this one right here has the copper in it. But if it happens to not weigh the same, then the copper ingot is in one of these groups. So say that this one was the heaviest. Then I know I'm just dealing with this grouping of 2. So what I would do is just weigh the ingots separately, and then we'll just say that this is the one with the copper in it. And that is how I would come up with the weighing of 3 weighings to find the copper ingot. Now I told you I'd go back and talk to you about that 6, but I'm going to change papers, or I'll move it down a little bit. Okay, so we have our 16 again. And we have decided that these 5s here weighed the same. So I'm just going to cross those out. I would separate my 6's, or my 6 into 2, 2, and 2. I find this kind of tricky. It's kind of playing a guessing game a little bit as I'm writing this, because having 3 groups of 2, it could either be this grouping, or even this grouping. So if we weigh this group right here, and they weigh the same, then I know that I am dealing with this 2 that has the 2 ingots in it. So I'm going to cross those out. And if this is the grouping that's odd, I would do 1 and 1. Now, weighing them separately, it makes it easier to figure out which one contains the copper. So say I weigh these, this one is lighter. This would be the one with the copper ingot in it. The question that was also posed to me was to see if I could find the lighter ingot in 3 weighings if there are 24 ingots. I'll just show you what we came up with. So here's my 24 ingots. I'll divide that by 9, 9, and 6. So I have a grouping with 9 ingots, and 6 ingots. I would weigh these 2 first. If they're the same, then I know that I'm working with the 6. And again, I can separate that 6 like I just did in the previous problem. However, if these 2 do not weigh the same and one of them is lighter, then we'll say that this one's the lighter one. I'm going to separate that into 3, 3, and 3. And then again, I'm just weighing the groups. If they're the same, then I'm working with this one. Which, however, looking at this, I could weigh them by ones. And that would get me to figure out which one had the ingot in it that way. And probably the simplest way. So let's look and see. I've weighed the grouping 1 time. And then 2 times. And then I might have to weigh it, well, definitely 3, but possibly a 4th time. So I am not quite sure or convinced that I would be able to figure this out in 3 weighings. By chance, I could probably do it in 3. So there's your 1 weighing, your 2nd weighing, and then maybe by chance this one weighed differently than this one. Then that would be your 3. The question was posed as well, if I'm able to make generalizations, is it possible to figure out how many weighings are needed for 100 ingots? Taking notes on this, we knew that one side would need to be lighter because of the copper on it, but also that we felt that it should be divisible by a 3 to make a single digit, and you would need it to be 9 or less to work out in 3 steps. Let me go ahead and show you the 100. I would divide it 33, 33, and 34. Again, weigh these two. If they weigh the same, then you know that you're dealing with the 34, which I'm just going to write it off to the side. Would we be weighing 11, 11, and then 12? And if these two weighed the same, then we're dealing with the 12, which then we could break up into 5, 4, 3, which is not going to work, so we need to do it 4, 4, 4. Doesn't make sense to weigh them in different amounts because it's obviously that the grouping of 5 would weigh the most anyway. So let's look at the 11. I would probably do a 3 and a 3. See if those weighed the same. Or possibly I could even do a 5 and a 5. That would get me 10. So if one of these is different, then I know I'm dealing with that grouping. But if they happen to be the same, then that one left would also show me that gold ingot. However, if I'm dealing with this 3, I would just need to go 11, 11, and 11. And then I could break it down again like I did up here. Let the 5, 5, and 1. I don't believe that it could be done in 3 weighings, and I'm not sure how I would go about coming up with a generalization. What we had thought of in the rule of thumb would be, it'd be 5 steps for 100, and those steps could also is for weighing for 100 ingots. And then 6 steps or weighings for 1,000 ingots. I hope that I was able to explain the solution to this problem that I came up with as clearly as I could. And hopefully there's an easier way to do this than I could figure out. And I hope you enjoyed. Thank you.